We've got two speakers tonight, Abel Gorigor and Robert Hanson. Abel's going to be taking us through building a Xamarin app in Visual Studio, and Rob's going to be teaching us about physical computing with .NET Core, which I don't understand what that means, but I'm looking forward to finding out. Okay, so the agenda is we'll go through this slide deck just quickly, and then I'll transfer control to Abel, and he can take us through his presentation, which we think Abel thinks it might take anywhere between sort of half an hour and 45 minutes. So I've gone for the middle amount of time on that, and we'll perhaps have a questions and answers session if Abel's okay to host that. Then we'll have a quick comfort break, and then we'll go jumping into Rob's physical computing presentation. Again, there'll be a little bit of time of questions and answers at the end, and then we'll close, okay?
Yeah.
And these are the standard meeting rules. We've not actually changed anything except this second line down. So we'll cover this. So please respect each other and their ideas. Whilst during the presentation, if we can all go on mute. If you disagree with what's been said, please challenge politely at the end of the presentation. Although this is hosted by BGL, these meetings are not for recruitment purposes. There's zero tolerance towards discrimination of any kind, and zero tolerance towards violent, dangerous and criminal behaviour. Although doing that remotely, I would argue that's a bit difficult to prove. The topics that are still on the list, we've got F#, Signal R, Visual Studio 2019, command line tools and serverless functions, and Albert's happily going to be talking to us about serverless functions. So
in this presentation, we're going to go through the step involved in creating a Xamarin Android application, and also at the end of it, I'll be able to just go through a simple walkthrough of a mobile app which I've created. My name is Abel Gorigor, a .NET developer at BGL. So, what is Xamarin Android? Xamarin Android is an open source app development platform that lets you build an application for many operating systems. Xamarin allows you to write apps that can take full advantage of the power, features, and performance of each platform. The platform I'm referring to here is Android and iOS. Although Xamarin can also allow you now to build on Windows platform. Xamarin Android is a framework that you can use now to create a fully native Android application using your C# skills. So what is Xamarin Android app? Xamarin Android app is built using Xamarin tools and libraries. The UI is created now from Xamarin wrapper around the native Android view, while the behavior is written in C#. The behavior can be any of our logic, our data access layer, utilities, and external libraries. I would say that as I'm going through the presentation, if you have any questions, please ask me. Okay. Using Visual Studio and C# to develop an Android application. Xamarin Android supports the latest C# features, including generics, async awaits, link, and lambda expression. So as a C# developer, if you are transiting or if you are going to start developing on the Xamarin platform, the learning curve is quite slim. It's not that stiff or complex because you are going to be using your existing skill set. You're going to be harnessing your existing skill set in developing a Xamarin Android application. So libraries. Xamarin Android app uses utility classes from 3 libraries. One of the libraries is Java. Xamarin Android provides a C# wrapper for all Android Java libraries. It also provides C# wrapper for all Android APIs. And also we have Mono, which is also included in the Xamarin Android solution. I want to say here that Mono is a subset of the .NET framework. It's an open source. And it also contains the common language runtime. As we continue with the presentation, these libraries, we'll begin to understand them the more. Xamarin Android also allows us to add third-party Java libraries into our solution. So suppose that we want to build an app, like a Bluetooth app. If we want to build an app like a Bluetooth app, we need an SDK, which is actually totally add from Xamarin and also add from C#. So we need an SDK, which we will need now to reference into our solution. In order to do that, Xamarin Android provides a binding project. With that project, we can reference any Java libraries, build the project, and reference the libraries into our solution, as if we're just referencing our normal DDLL or any other C# libraries. So yes, the Xamarin Android allows a third-party Java libraries now to be included in our Xamarin projects. At this point in time, do anybody have any questions? Questions? No questions? Okay. So how does Xamarin Android compiles? So how does the code compiles? The code we wrote in C# or developed in C#, they are compiled into MSI and then packaged into an assembly. So though we are working with Xamarin Android and we are using our C# skills, during compilation, our C# code will be compiled into an MSI, Microsoft Intermediate Language, and then being packaged into an assembly. MSI cannot run on its own. An MSI will require a common language runtime to be able to run or to be able to be executed. The Android libraries which are actually wrappers of C# that we're going to see into it later on as we continue the presentation. They are actually not written in C#. They are written in Java. So during compilation, they will not be compiled by the C# runtime or the mono runtime. They will be compiled by the Android runtime, which is called an ACT. So we have two runtime whenever you're actually writing or developing using the Xamarin Android platform. One, we compile our C# codes, including all our libraries. While the other runtime, which is the Android runtime, we compile all the wrappers that we have included in our application, and also the libraries, which we have actually also included in our application. So we have two runtime, the Android and also the mono runtime. Understanding Xamarin execution. As I've said earlier on, our C# codes, the .NET libraries, they are all going to be handled by the mono runtime. Our C# wrapper to Android and also any other Java libraries, they are going to be handled by the Android runtime, which is called an ACT. An Android operating system, it sits on the Linux kernel. And whenever we package or build our Android application, it's built into an APK, application package. And this application package has these two runtime in it. The mono runtime, which enables MSI to be executed, and also the Android runtime, which enables the Java libraries and Android libraries to be executed. During installation, when the app is actually being packaged into the APK and being deployed now to the end user devices, during the installation, which happened only once, the APK is actually converted to an Android code that will be executed by the Linux kernel. This Linux actually talks directly now to the operating system. So that's actually the process that's actually involved in getting our application now to be executed within the Android operating system. Any question at this time? Okay. Hope I'm making sense. Xamarin Android support broad range of devices. So it's not only limited now to just phones. It also can operate within tablets. We can develop on tablets. We can develop on Android wares like watches, Amazon Fire, large TV sets. So you have a choice. If you are actually a Mac developer, or if you have a Mac operating system, you can use Visual Studio for Mac. And if you are actually a .NET developer, if you are actually using Windows, you can also use Visual Studio, Microsoft Visual Studio. In each of these platforms, Visual Studio actually provide an installer. So whenever you install Visual Studio, And the installer gives you an option to install the Xamarin. If you decide to go through that route, the installer will install the JDK, the Java Development Kit, and also the SDK, Android SDK, and also the Androids and Mono. As I said earlier on, Mono is a subset version of our .NET framework. So it's a smaller version of our, our big .NET framework that executes the MSI that is actually produced from the Xamarin platform. Development workflow. Microsoft Visual Studio provides project templates for developing Android apps. So we have several templates within Microsoft Visual Studio. You have templates that you can use directly now to create an apps. You have templates that you can use to create a binding project. Binding projects allows to use external SDK, third-party libraries, third-party Java libraries. Also within the Visual Studio, we have a UI designer. The UI designer enables us now to develop the user interface. The UI designer can be of two forms. It provides a drag and drop, so where you have these very different views, you can easily drag and drop them and create your UI, or you can decide to use the raw format, which is in the form of XML. Which also provide emulator. So you can use an emulator now to test your app. Once your app is on running, you can use the emulator now to just have a feel to see how it's going to perform in the end user devices. You can also connect your app directly now to your device if you decide to choose that option. Xamarin app structure. An Android app is a collection of collaborative parts called activity. An activity is the basic block of an Android application. An activity is actually in two forms. We have the UI and also the code. The UI is where we have the look and feel of the application, while the codes actually control the behavior of the activity or of the application. I want to say that if you have actually developed web form, if you've developed web form before, if you've developed application within the desktop application using web form, you find that we have the UI section and also the code behind. The UI section is where you have to drag those various controls into it. And the code behind is where you have to listen to the events of those various controls and act on them. It's also the same thing here. And I want to also emphasize here that the UI and the code, they are tightly coupled. So whenever you have a UI, you're going to have a code. So we don't have a UI separately and we have a code separately. No, it's not loosely coupled like MVC. It's tightly coupled. So if you have a UI, there must be a related code to it. And again, if I want to, before I move further, activities actually define a single user task in an application. So every activity must have a single user task. Like the app we're going to be looking at later on, we have a splash screen. So the task for that particular activity is just to display the brand, the logo of the app, and that's it. We can also have other activities like registration activities where you have to fill in your details and submit. So an activity defines a single task. Activity does not define multiple tasks. It's just a single task. You can achieve a single task and move now to the next activity. A continuation of activity. An activity XML file defines the UI. So if you look at this, the other side of the diagram, we have two sections. Although we have the Pi ASMS, I think that's an old extension. It's supposed to be an XMS, which actually defines how the UI look like within the XML file. And the other section defines the activity in code format. So we develop our UI using the XML, and the code format is written purely in C#. And we're going to look at what the activity stands for, these activity attributes, and also the base class called activity when we get down to our demo. So what is Vue? Vue is the fundamental building block of Android UI. Vue is the part of the UI which we can see and sometimes feel. Vue have a virtual component and also a code behavior. Again, if I have to go back again to the examples which I made use of before, concerning developing app using a window form. The window form, those controls you drag into the window form, they are all views. But they also have some code path as well. Because if you click the form, if you click any of those buttons, they respond to a click event, which need to be handled within the code side of it. So what I'm saying here is that a view, though it has a visual part, it's also tied to a code. It's also tied, it also have its own code path as well. The difference between a view and activity is that a view is not tightly coupled. It's not tightly coupled. So the UI can stand on its own. We have view that does not respond to a click event, like a label. It's just to display a direction, like entering the numbers of these digits. It's a label. It's a view, but it's a label. But the calculate pi is a view that is tied to a code. View hierarchy. Vue has hierarchies. As I said, Vue is the fundamental building block of an Android UI. So whatever UI, if you have an Android app, or if you have an Android phone, whatever UI you are seeing, you're scrolling, your app bars, they are all built from view. View has a parent object. View inherits from a parent object, as all C# objects inherit from the C# object as well, system object. Also, view inherits from an object. Controls like buttons, text boxes, switch buttons, they are all derived directly from view. View groups actually derive directly from view. View groups, they are like collections of views. If I would say, if you've actually downloaded BBC app or CNN apps, you see that whenever you scroll through the news, if you have that, if you use your app to move down or to scroll to the next news, these are all you're going to see list of different news. These are all view groups. We also have layout panels. Layout panels, they serve as containers where you can design your app layer. So layout panels enable us now to add views that defines the structure of our UI. We're going to look more into the layout panel when we get to a small demo. Let me see. Before I get into this, I would just want to emphasize again that under the layout panel, we have 3 different layouts panels. We have the linear, we have the relatives, and we also have the grid layout. I think we also have table as well. But in this demo, we're going to be working more with relatives layout and also linear layout. Both of these layouts, they are going to serve as the base container for our UI. The scope of our demo. Initially, my plan was to create and decompose an activity, build the activity UI, write behavior, and deploy that to an emulator. Because of time constraint, I will not be able now to go through each and every one of these steps. And again, my emulator will not allow me to do that because the emulator is so powerful. If I decide to run it, it's going to drain the entire internet power and crash this presentation, which I will not want to do. So I've actually compiled the demo into an emulator. So I've compiled it and deployed it to an emulator. So emulator is more like just mimicking a physical device. So we'll be able to see how the demo will run. Explore Xamarin app. At this point, I'm going to shut down the presentation, and we're going to go into the Xamarin for Visual Studio. We're going to look at the structure of the app. How is it like? Where do we store our various views? And where do we store our activities? And what actually make up the Xamarin Android app? So I'm going to stop sharing. So we'll be able to see the Visual Studio codes. Or before I do that, let me just run this, because I don't know if I'm going to be able to bring up the slides again. So let me just run through what we're going to be looking at. So the app that we're going to be looking at is a simple app which takes in a JSON feed, a movie JSON feed, and display it as a list of different movies. And if any of those movies is being clicked, it moves now to the details of that movie. I've tried as much as possible to build the app like a real world app. It's not like a sample app. So I've added all that I need to add to it. So if anyone that's actually interested in it, you can pick it up and use that as a base now to start or to kick off your career in Xamarin Android. So we have 3 activities. Remember, as I said earlier on, activity is the basic building block of a Xamarin application. An activity has two forms, the UI and also the codes. So here we're having the first activity is actually a splash screen that will come up and display for like 1 milliseconds and move to the second activity. The activity, the UI comprises of a relative layer and also an image viewer. We're going to look more into the codes later on. The next activity is actually the movie list, which takes in a JSON field and displayed in this format. The UI consists of a linear layout, an app bar. The app bar is this movie you're seeing, this where we have the movie, this blue screen is called the app bar. And also the recycler view. The recycler view is more like a list view that enables us now to display the movie in this format. Within the code, we have the adapter. An adapter is a class that serves as a bridge between our data source and the UI component. So the adapter takes our data source in any format and converts it to this structure that we are seeing. So it converts it to any predefined structure. That's what the adapter does. We also have the view holder. So what the view holder does is, let's take for instance, what you are saying, now this Batman, the Batman has we have the label there called movie, then we have the name, then also the year of release, then the big picture there. So what the view holder is doing here is, it takes these various structure, these labels, all right, and represent them in C#. That's what the view holder does. Then also we have the recycler, which enables us now to display it the way it's being displayed now, display it in a list form. Then we have the HTTP. The HTTP client is an hybrid, which I created from our normal HTTP client that will enable us now to make a request now to the RESTful API and get back the response and feed it now back now to our adapter. And our adapter feeds now to our recycler and being displayed in this format. This Picasso, it enables the image now to be displayed seamlessly without having frictions. It controls how image is being displayed. In case that actually, say for instance, I made a request for an image and the image is not there, with this third-party library, I would be able now to control, instead of displaying a blank or an error, I should be able to control what I sent back now to the activity view by displaying an alternative image. Then the next one is actually, the next activity is the movie details, all right? So whenever the activity list is being clicked, it takes us straight now to the movie details where we have more information about the movies. So within the view, we have the linear, the app bar, the cards. We're using a different view type there called cards, and also image. And within the code, we have the HTTP, the movie details, and also the speaker song. Any question? No. So that's it. So let me just rush through the structure of an Android apps, and then we'll be able to see how the code looks like. Stop sharing. Where's my C#? Okay. Okay, so this is actually the structure of a Xamarin. This is how the structure of a Xamarin app look like. So it's not different from what we have been doing as a C# developer. We can still have different libraries, and we can still build our projects the way we usually do it. But there are some few differences which I'm going to run you people through now. One of them is the asset folder. This asset folder enables us now to add non-code files into our project. Suppose we are building an apps that contain a lot of images or contains videos. We can just dump the videos here, or we can dump the images here. We also have the resource folder. Within the resource folder, we have the drawable. The drawable enables us now to add images to our apps. So all images that we're going to be adding into our app, static images, we place them within the drawable folder. The logo for this particular app is actually being placed here in the drawable folder. We also have the layout. So the layout contains the activity UI. All activity UI, they are being stored within the layout. The layout is made up of an XML file. So if you need to add a layout to your activity, you do it here. What you just need to do, the way you add items within normal.net, you just do that. You click the add new, and you'll be taking that to the various views. This is a blank XML file, which you can add now to your activity, add to your layout. And from there, you can design your UI. We also have the various MIP. This is where you store various size of images. Now, suppose we're actually developing now for tablets, or we're developing for a large TV screen. We can add different images, different size of the images into this folder. We also have the values folder. The value folder is where we store one-time values that will not change during the lifetime of the application. Constant. This is where we add it. Constant for the UI. And also, we can also reference this constant within our codes. Also, we have what is called a color. This color files, you can use it to create a theme for your apps. So if you want to create a different look and feel for your app, And with those look and feel can be changed during runtime. You can add the various colors here. And finally, we also have the resource designer. The resource designer is actually a file that is generated automatically. So whatever files, whatever layout file you're actually creating, Visual Studio automatically assigned a unique ID to that file. So that particular file can be referenced from the code. So we're going to see how that works later on. So this actually all you need to know, and this also the entire structure of the Xamarin app. Sorry, you people cannot ask questions from here now because it's virtual. Okay, so let's look at the activity, the code side of the activity. We're going to look at the splash screen. I've already created the splash screen. So there's the code now for the splash screen. So I decided to name it as splash activity, right? It's not a convention, so you can decide to name it anything you want to name it. All activity within the Xamarin Android must inherit or must extend the activity base class. But in this app, I'm using app compact activity, which is an extension of an activity base class. So with this app compact activity, we also have the activity in it. It's just an extension of the app, or it's just an extension of the activity. And also, for every activity that you are going to be creating, you need to annotate that class with the activity attributes. So you can see here we have an activity attributes that have several properties. These properties control the behavior of the class during runtime. For this demo, I'm just using the label, which will enable me now to give this splash activity a more user-friendly name. And also we have another property called main launch. The main launch here tells the operating system or tell Visual Studio during runtime that this activity is the entering point of the application. Okay. So within the activity, within the class, I'm overwriting the Oncreate. For each activity, there is a life cycle. Every activity have their own life cycle. I would not really want to dive deep into that, but one of the methods within the activity life cycle is called the Oncreate. We have the onStart, the onResume, the onPause, the onStop, and also the onDestroy. These are various activity life cycle. So the moment you start browsing, using your applications, your app goes through these various life cycles, right? So the first one here is called the Oncreate, which more like it bootstraps the activity. So once the activity is being kicked off by the Visual Studio, right? The first method that will be run is called the Oncreate. The Oncreate takes in a bundle with a parameter called save instant states, right? Which initialize the base class. what happened here is that because an Android app works with a stack, which is more like a first in, first out. So whenever you browse you're using your app and you decide to move into another app, what happens is your app, the other app is going to be pushed down into the stack. And if you decide to move out, your app, you move back into your app again, your app will be pop up, it moves into the top of the stack. And in order to maintain the states which you left it, the save instance state tends to do that. It saves the states of your app as you navigate into other app or other activities. We also have another method here called the set content view. The set content view creates the binding between the activity UI and the activity code. If we look at the layouts, we have the splash XML. The splash XML is the UI for this particular activity. So in order to bind it, we use the set content view. And as I said earlier on, whenever you create a layout, the layout is automatically assigned a unique resource ID. So the set content view uses that ID to bind the UI. So if I hover my mouse over this splash screen, you're going to see a unique ID generated now by Visual Studio. So the next bit of the code here is the run on UI thread. I will not want to spend much time on this. The run on UI thread is a C# wrapper of Android libraries. The C# wrapper is not actually a .NET class. It's a C# wrapper to Android library. So what that does is it enables the activity to run within. It enables the code, the block of code, to run inside the splash screen thread. Okay, and also this handler is also a C# wrapper as well. But what I want to explain here before we move down to the other activities is called an intent. So an intent is a class that actually facilitates the communication within other components. An intent can take in parameters. Here, we're going to use the intent to communicate now to our next activity. So I've created an instance, set class. This is actually referring now to the context, which is the splash activity, and type of main activity, which is going to be our next activity. Once this particular screen finished running, the next activity, which I want to be loaded automatically, is going to be the main class, the main activity, which is going to be which the application is going to navigate through the help of the intent. To start an intent, you use the start activity. Start activities also is not a C# library. It's a Java library. It's a wrapper. So we have access. One of the beauty about Xamarin is that we have 100% access now to the Android API. So whatever we can do in Android, in Visual Studio, in Android Studio, we can still do it here. The various APIs that's actually available within the Android Studio, we can have access to do that using our .NET skills. Do you people want me to run it? No. Do you want me to run it? If I run it, it's going to crash the entire. But I can stop it and run it through the emulator. So I'm going to stop it now so I can run it so you people can see it. Huh? Okay, so this is actually the emulator. This is the emulator. I've compiled, I've built the application, the apps, and I've deployed it now to the emulator. So the app is actually called Splash Screen. That's what the launch logo, the launch label is. So I'm going to bring it up. Oh, sorry, because I actually loaded this. I'm going to move back again. Okay. So it's going to load the splash screen. That's just the splash screen. So short. So this is the splash screen you're seeing here. The next activity is actually the main activity, which is this. So the moment the splash screen comes up, all right, it runs under the main UI threads and moves automatically now into this main activity, the main screen, which lists the movie. Graham, do I still have time?
Yeah, I think you've got a few minutes. Yeah, I think you're good.
Okay. Let's go back again to this. Okay, so we're done with the splash screen activity and also the UI. We're going to move now into the main activity, where we are going to see how we're going to call the external API, pull the JSON objects, bind it now to the adapter, bind the adapter now to the recycler view, and display it now into the main activity is going to display the list of movie. Again, as I said, every activity has a UI. So we have the UI, this is the UI in form of XML, and also the same time, we have the visual part of it. I would not want to spend much time in explaining what all this stands for. But the main view that I'm using here, as I said earlier on, we have view groups. And view groups consist of linear layout, relative layout, tables, and also grid. And they can serve as a container to other view. They enable us now to build the structure of our UI. So here, I'm using the linear layout. And one of the beauty of linear layout is that it enables us now to arrange our views in different orientations. So we can arrange all our view in vertical, one at the top, or we can arrange them in horizontal. So most of the apps, again, if I have to go back again now to CNN app, BBC app, because actually I spend most of my time going through the news at this point in time of my life. So, and I tend to look at the apps, which, the technology behind it. So they made use of the vertical layout a lot there, right? So the vertical layout enables us now to put one item on top of another, right? We're going to look at, when I have to do the demo again, I'll be able to explain it more. So I'm using a vertical layout, I'm using a linear with a vertical orientation. So every other thing will come on top of, below each other. So we have the app bar, which is this green thing this blue you are seeing. It's called the app bar, right? And within the app bar, we also have the toolbars. With the toolbars, you can add additional, what is called an icon. So if you look at your mobile, especially if you are working with WhatsApp, if you look at your WhatsApp, you can see that within your WhatsApp, you have different icons within it. So they are all actually stored in this app bar. Then also we have this recycler. So the recycler is actually a list view, all right, that enables us now to display very large amounts of data in a smooth and in a more efficient way. These are all wrappers. They are all C# wrappers to Xamarin. They are native to Xamarin. They are not actually C# code. They are native to Xamarin. These are actually Android. Okay. So yeah, so this is actually what make up our UI. So let's just rush that through because I've been told that I have very short time. So we just look at the main activity. I've actually set up some few methods here. We have the attributes, which is main, and we're extending the app compact activity. And also we have the bootstrap method, which is called the Oncreate. Then within it, I've set up some few other classes like initialize the toolbars. I'm initializing the toolbars from codes, and also initializing the progress bar, that's thing that spins when the app is up. Then we also have the initializing the recycler, right? So I'm actually referencing the recycler from the UI. I create a reference. I'm referencing the recycler view from the UI. And I think this is the method which actually we are interested in. So this is a small HTTP client class which I created. It's an hybrid which we fetch the data instead of us now using an if then else now to check if actually the call to the API is successful. It's going to fire up two events. One of the events is successful and the other one is actually an error. So we subscribe to these two events. So if it's successful, it's going to come here. And if there's an error, it's going to come here. Okay. If you are interested, as I said earlier on, this code is going to be available in GitHub. So you'll be able to pick it up, run the app yourself, and understand these various processes. So yeah, once the splash screen navigates now to this particular screen, the main screen, this particular method is fired. I've actually hard-coded the keys. These are the API keys. I've hard-coded it. So it's going to go straight now to the API, all right? Fetch the data. And if the data is successful, it's going to fire this particular event. It fires the event. And this particular, because I've subscribed to the event, is going to come here. Okay? These are all codes which I've written. So you'll be able to see these HTTP arguments. You'll be able to see everything. If you can download this particular code, you'll be able to see what the HTTP argument stands for. You're going to see the adapter, and you'll see the various code involved in it. Because of time, I will not be able to go through them. So once the unsuccess is being fired, it's going to return back a response. And the response, with the help of this HTTP, it converts that response to the movie model. I've created the movie model, which is this one. It's going to convert it now to the movie model, right? That movie model is going to be passed now to the movie adapter. And the movie adapter will be passed in to the recycler, which displays the list of movies, right? And again, within the list of movie, I've created also a listener. I created a listener. I subscribe to a listener. So once you click any of those movies, right, it comes down to this place. It comes down to this on item click method, which actually uses again the intent to navigate now to the movie details activities. But this time around, I'm passing in two parameters. I'm passing the movie ID and also the movie title, and the activity will now kick off and navigate now to the movie details. The movie details, which is this one, takes in those two parameters. I'm trying to rush now. It takes in those two parameters, which is this. It takes in those two parameters. If you observe here, get string extract. It takes in those two parameters. It takes in those two parameters, but I'm using only the ID of the movie to go and fetch the details of the movie, following the same pattern, all right, on success and on errors, which I've subscribed to. So once the fetch is completed and is successful, it's going to fire this onSuccess method, which displays the movie details. But if there's an error, it's just going to write it into the log. So in summary, Xamarin Android enabled .NET developer to create fully native Android apps. Developer can annex their full power, their full skill set, and all they have learned in C# in order to create a robust application. Developer can also use the full advantage of the power, features, and performances of the Android platform. Thank you.
Well done, Abel. That was very good. I'm sorry I had to rush you there at the end.
Yeah, when you start rushing me, just piling pressure.
Sorry about that. Sorry about that.
So if you have any question, I'm happy to take some few questions. As I said, this code is going to be available in GitHub. It's quite a rich code, and it can help you now to kick up your career in Xamarin Android. It's quite interesting to be able to use our C# knowledge developing in a platform which we are familiar with to create apps like this. Whatever you see, like what's it called, WhatsApp, BBC, CNN, or whatever apps you may have downloaded and come across in your Android mobile phone, this is actually how they develop it. There is no other thing that is different. It's that simple. Okay, so if you have any question, I'm happy to answer your questions. Otherwise, we want to hand over now to Rob Hansen.
Just a quick one from me. This obviously was a demonstration for doing it on Android. Is it much different able to do it for iOS?
There's not much difference because the codes, the data access code, the HTTP client you were seeing the other time, the adapters, these are all shared codes. The utility classes, they are all shared codes. So the only difference is the UI, because UI, they're actually natives. They are native to that particular platform. So you can share your code, your C# code, you'll be able to share it properly, but the UI, you have to create a unique UI for that particular platform. So if I'm going to add an iOS to it, I'm going to create a unique UI for an iOS, but I'm going to share the other codes. All my C# codes, I'm going to share it.
Thanks, Abel. Can I ask you a favor? If you could stop sharing your screen and just make me the host. Does anybody, whilst Abel's doing that, has anybody got any questions for Abel?
I've got a whole bunch of questions, but in in the interest of time, where does Xamarin sit in terms of sort of how popular is it? So in comparison to things like React Native, for example.
The essence of Xamarin is to attract .NET developer into, is to just like attract .NET developer into the mobile world. You know, it seems that the .NET developer, they are being caught unaware. They are actually C#. They've been doing C# all their life, web forms, MVC. Now we're not talking about mobile apps, right? And mobile apps, we have two unique platforms. Microsoft could not, was not able to get into it. It does not have a good share of the market. So we have Android and we have iOS. So in order to attract .NET developers, so they cannot be left behind, right? So that's where Xamarin fit into it. Xamarin is just like another layout, trying to ease it so .NET developer will be able now to do something now within the mobile world as well. Where Xamarin sits at the moment, it's a little relatively low because it's not really attracting a lot of developers, right? Because most developers, they are not C#. Most of the .NET mobile developers, they are Java developers. They deal with Java. So they are not actually C#, right? So the market, the developers that are actually using Android is quite relatively small, but it's interesting. If you have these C# skills, you'll be able to do a lot with it. You can see now that app that I demo now, it didn't actually take me much time to do. So once you get yourself used to it, you'll be able to develop any apps you want to, anything you want to do, anything that they can do in Android, you'll be able to do it here. So it doesn't really matter if we have React Native, right? Or we have Flutter. I can develop in Android Studio. I can develop in Flutter. I can even develop in React Native, all right? But I think I find it much more easier to develop the same thing, the same energy that I'm going to use in Android Studio. I can also use it in my Xamarin Android, which is really, really simple for me. I don't have to spend my time learning how to debug anymore because I'm used to it. So yeah. Any other questions? You say you have a bunch of questions. One more.
I do. I don't know if we've got time for them though. What else did I have? Are you tied to Visual Studio full blown? Can you use VS Code at all?
At the moment, yeah, I think you're tied to Visual Studio. You cannot use VS Code. As I said, VS Code, although VS Code you'll be able to use now to create your UI, so you'll be able to use it now to create your code behind. But at the moment, I don't know if Xamarin cannot be supported from VS Code. But you're tied now. At the moment, you're tied now to VS Code. To Visual Studio. It's quite a very big platform. You know, having Java running side by side with Mono, it's quite big. So you need to set up your system properly now for it to run. But it's really good. I want to recommend it. I'm trying to promote it here. Okay. Any other one again?
How much of an overhead is downloading Mono when you install the application?
I don't think there's much overhead there. So once you download Visual Studio, right? You know, Visual Studio installer will give you an option what you want to install. So from there you'll be able now to click your Android Xamarin. I think you'll be able to download. I don't really know much how big it is.
Yeah, I was thinking more when you install the app on the mobile device rather than installing Visual Studio. But
are you talking about installing?
Perfect. Okay. So my name's Rob. I'm obviously a .NET developer, and today I'm going to be talking to you about physical computing with .NET Core. This presentation is going to be significantly shorter than Abel's, so we should be done fairly on time. I'll say that this is kind of an introductory session. I don't profess to know everything there is to know about this. So I'm going to talk to you a bit about what it is, a bit of theory to start off with. I'll then talk for a bit about what I've learned specifically, a bit about how you can get started doing it with .NET Core, and then I'll tell you a little story about what I did with it personally, and then if we're lucky, I'll do a live demo at the end, so you get like the tension building up to the live demo, which is great. So crack on. What is physical computing? It's a lot simpler than it sounds in truth. I think the easiest way to explain it is by starting with what it's not. So it's not traditional human-computer interaction. So traditional HCI is where you have devices that connect to your machine that allow you to interact with it. So things like keyboard, mouse, trackpad, your screen, speakers, touch, etc. Sorry, it just says Albert's in the waiting room. So traditionally, your software is built around these boundaries. So you build software around having a keyboard and a mouse, etc. What the paradigm of physical computing is around is shifting this boundary. So software systems aren't built around the limitations of a keyboard, a mouse, a screen. The hardware and software are designed to interact with the physical sort of activities of the human body. So changes in pressure, changes in light and heat that the body can affect. So physical computing is building and configuring hardware and software solutions to sense these changes in energy and convert them into meaningful actions. Again, it sounds quite complicated, but it's really not. Again, what it's not is robotics. So robotics, there's a clear distinction here. Robotics are autonomous systems. So they work independently of humans. They might interact with humans, but they can function without them. They don't need human interaction. Whereas physical computing is directly designed around the activities of the human body, if that makes sense. So why would you do physical computing? There are lots of reasons. So there are some very interesting tangible UIs used in education. So where some learners don't learn very well by being talked at or talked to. They don't learn very well by reading. They learn by interacting with things, pressing buttons, moving things around, just using their body to interact with a system rather than the traditional way. Medical. So, for example, the breathalyzer that you might take on the side of the road after driving home. It's a system that reacts to your breath. Same with like a heart rate monitor. It reacts to the pulses coming out of your body. There are some artistic installations around this. So there's quite a lot of stuff at the Science Museum. There's lots of things you can interact with. A massive one these days is in the home. So smart devices, lights, smart lights, smart TV, various IoT devices that can sense things like temperature and pressure and react accordingly. Another one is games. So the only examples I've got for this are, do you know the Bop It game, where there's like it's a thing and you have to twist it and smack it and you do stuff with it, but it's around how you interact with it. There are dancing games where you move around and it senses your movement. So again, it's not keyboard and mouse, it's about the human body and what it can and can't do. The reason I became interested in physical computing is just because it's just an area to get into, it's something to do, it's a side project. So as a developer, you find that you grow more by having these side projects. So where I work in insurance, we don't do a lot of physical computing, we tend to do traditional computing. So having a side project like this enables you to grow as a developer and broaden your skill set. I guess it's why we come to things like this, is to grow and to learn. So to get started, what do we need? We need a few things. We need a microcontroller. So this is the simplest way to get into physical computing. They are very simple computers that can be connected to components to interact with the physical world. They're typically really lightweight. They might not run an operating system because they have a very specific activity that they need to do. So they can be built specifically for that with no overhead or very little overhead. They have very little memory or processing power, but they usually have some kind of pins in order to interact with other components or other microcontrollers. So for example, in your phone, you're going to have multiple microcontrollers that do specific things. So one for the touch screen, one for the one for various buttons, accelerometer, GPS, etc. You also need components. So these are the physical devices that will do the sensing and the responding to our interaction. So obviously there's tons of different components out there that can sense things like, as I said, heat, light, temperature, movement. And when we combine them all together, we can build some really complex systems. I mentioned before about the educational part of it, where some learners learn by interacting with things, and you can build up some really sort of big, both physically and in complexity, tangible user interfaces. So this is where you have an object, a physical object in the physical world, where when you interact with it, it mimics something in a system. So the best example of that is a mouse. So this is a mouse. And when I move it around, the cursor moves on the screen. So the mouse is a tangible physical representation of the cursor. It's the easiest example of physical computing out there. The other thing we need is the software. And to me, and presumably to everyone on this call, that's the fun part. So we build the software to handle receiving and interpreting data from sensors or input devices and taking the appropriate action. So the appropriate action can be whatever we like. It can be an internal process that doesn't provide feedback. We could log the data that's received from the sensor, or we might call another device to produce another physical response. It really is up to us. So the most commonly used microcontroller out there these days, I think, is the Raspberry Pi, which you may or may not have heard of. It is an absolute phenomenon. They've sold, I think, over 30 million worldwide. I went with the Pi because it's the easiest way to use .NET Core to do physical stuff. And I'm not really interested in the sort of electrical engineering side of it, or the electronics or circuits or anything like that. And the Pi makes it quite easy to build stuff like that without having to have too much knowledge. I've used them before for using Bash and Python, things like that. And yeah, it just provides the easiest way in. You can get one for about, I think, 34 quid for the cheapest one, but the more powerful ones have like 8 gig of RAM now, so they're you can get quite a lot of grunt in quite a small package. The other thing you need is an operating system for the Pi. So there are obviously lots of them out there. The most common ones to run .NET Core on are either Raspbian, which is the original Pi operating system. It's the first one that came out when the Pi was released. I think it's now called Raspberry Pi OS. They've rebranded it. The other option is Windows 10 IoT, which obviously is the Microsoft Windows specifically built for Internet of Things devices. So I tried out Win 10 IoT because I wanted to try it out, and it looks nice. That is a screenshot of it. That's pretty much all there is to it. And it worked. You can connect to it from a Windows machine. I did find it a little bit clunky after a while. It would drop connection, and it'd need rebooting every now and again. So rather than get too sort of elbow deep in trying to sort out the problems, I just binned it off and installed Raspbian. So Raspbian is a Debian Linux-based operating system, which is specific to the Pi. It's super reliable and comes with all the good stuff that obviously Linux does. The problems with Win 10 IoT might have been because my Pi is an older model. I think it's a Pi 3, that one. So the Pi 4 is the latest one. You also need some components. So these are the physical devices that are going to sense input or create an output, or they're going to be somewhere in the middle where they handle some physical responses. So obviously there's lots of different things you can connect, and as I said, I'm not an electronic engineer, so I'm not massively familiar with all of these, but we need to select them and build the appropriate circuits to allow them to communicate with our microcontroller. I'm not going to talk about it too much because I don't know that much. We also need a dev environment. So I went with VS Code because again, it's what I'm familiar with. If you go with VS Code, you can build stuff in .NET on the Pi in 3 different ways, kind of. So you can build it on the Pi using VS Code. So you install VS Code on the Pi, connect it to a monitor, keyboard, etc. Tap away, compile, run, etc. You can alternatively build it on a different machine, so Windows or Mac. Write the code, compile it, punt it over your network to your Pi. Obviously, that means you get all the power of your dev machine, and then you just pump the compiled code over. So, which is nice, because obviously you get all the rich IntelliSense and all that good stuff. The third option is the option I went for, is where you install VS Code on your dev machine, but you connect to the Pi over SSH through VS Code because it's got a nice extension, which means you can have the code on the Pi. So you write the code on the Pi, you compile the code on the Pi, but you do it from your Windows or Mac machine, which is kind of a nice sort of hybrid between the two options. And obviously you get the familiar environment of your dev machine. But I guess the drawback of doing it that way is your dev machine is most likely to be more powerful than your Pi. So when you compile and run, it takes a little bit longer because the Pi isn't as powerful. So to do that, as I said, you need the remote SSH VS Code extension and an SSH client installed. So I'm running Windows, so I had OpenSSH installed. You also have to install the .NET Core SDK on the Pi, 3.1, but 5 preview is out and works. You need the ARM64 version of it, because that's the CPU in the Pi. I think from the Pi 3 they went 64-bit. Prior to that it was 32-bit. So, hello world. So our normal standard hello world in almost every other language is write some sort of console application that says hello world. So in the physical world, the simplest thing I can think of is turning an LED on and off using .NET Core. So what we need to do for that is to connect via a very simple circuit an LED to the Pi via its general purpose input-output pins, or GPIO. So once we've connected them, so you can connect it, the Pi outputs either 3.3 volts or 5 volts, and obviously has a ground. So you connect the circuit to the 5 volt, you connect through the LED back to the ground, and it lights up. But what we want to do is control that via the Pi. So we want to control whether it's on or off. So the Pi provides, I don't know how many, I think it's 40 GPIO pins, and they've all got, it's got like a numbering system. So they're not always inputting or outputting, they're not doing anything. You have to control them with software. So how do we control the input and output pins using .NET Core? And the answer is using the .NET Core Iot libraries. So having done some Pi stuff before in Python, I was delighted to find that there are these .NET Core Iot libraries. I want to say it's a product of the open sourceness of .NET these days, because a lot of these are community contributed packages. So it provides two key libraries, the device bindings and the other one that I've forgotten the name of. Oh yeah, the system.device.gpio. So system.device.gpio gives us that abstraction to communicate with those GPIO pins. So we can say at this time, send a signal from pin 7 to light our LED. The system.device.gpio library has some specific classes to interact with specific components. So we'll get onto it later, but they're really good because they take away they abstract away the complexity of these components. So having done some of this before in Python, you have to do all that yourself in Python. With .NET, there's a library to do that for you, and it's great. So, hello world, let's have a look. Now I've got some code which hopefully will work because it's connected to my Pi, as I say, remotely. So it's over SSH. So the code is sitting on the Pi, and you connect via VS Code. So hopefully the connection hasn't dropped while I've been chatting. No, it's all good. So hopefully you can see that. So here, so you can see there it's connected over SSH to a local IP address, and when you connect, obviously it asks for your password to your account on the Pi. So I'm connected as my user, Mr. Pi, on that machine, and all this code is sat in a folder inside the project's directory. So when you first connect, it asks you what folder you want to open, as you normally would in VS Code, and it gives you the options from the file system on the Pi. So from there, I created a simple .NET Core 3.1 console application by running .NET New console, and went from there really. So we'll start with program CS. So the intention of this is to write a console application that will light the LED when I hit enter and turn it off again when I hit enter again. So to do that, I create a class called LED Handler, and I'm passing in the integer 17. So 17 represents the number of the pin that the LED is connected to. You'd think they'd be in order, but they're not. So you have to Google the map of the pins, which one's which, because they're not actually marked on the Pi. But trust me, it's connected to 17. So we've got a little while loop that reads from the console, and it calls, when enters hit, it calls the toggle LED method in our LED handler. So if we have a look at the handler, what we have here is our system.device.gpio, which is the package from the Iot library. So we're including it here in the CS proj to say that's where we're getting it from. And what that gives us is this Gpio controller class. So this is a class that enables us to call methods to interact with the general purpose input output pins on the Pi. So what we're doing, we're newing that up in the constructor, and we're then calling the open pin method, which kind of initializes that pin, and we pass it the number of the pin and the output mode. So this is an enum to say whether it's input or output. So we're using output because we want to send current to the LED from that pin. When you connect to other devices, you might be sensing something, so you might have it as pin mode input in order to receive a signal. So we've got some methods to turn on and off the LED. So turning it on is as simple as sending a write, calling the write method on the controller, again passing the LED pin and passing the value we want to send. So pin value.high again is an enum. which says send that current pin value low is to turn it off. I won't run this because I haven't got the, I can run it. Go on then, I'll run it. So there'll probably be an awkward few seconds while we wait for it to run, because when you run stuff, not when you run it, when you compile stuff on the Pi, it takes a little bit longer because it's not as powerful. So what's going to happen here is it's going to run through this while loop, and it's going to wait for me to hit enter, and when it does, it will toggle the LED by calling this class and calling one of these two methods. So there we go. So when I hit enter, this is me interacting with it, and it turns on the LED, it turns it off, it turns it on again, etc. Unfortunately, you can't see the LED. So that's our hello world. We know now how to interact with the physical world. So I'll jump back to the presentation. Yeah, so there is no live demo for that. Sorry. So what now? So at this point, I'm going to tell you a bit of a story as to what I did next, because we have a microcontroller we can run .NET apps on. We know we've got libraries. That means we can talk to physical devices. The problem a lot of people have when doing stuff like this outside of a business context is that you don't have that driver. You don't have the business coming to you saying, I need a solution for this. I've got this problem, build me something. It's hard. So I'll tell you how I came up with something. It's kind of a convoluted story, but I'm going to tell it anyway. So this is a car, as you might know. This is my friend's Pontiac car. He's very passionate about cars. He's very passionate about this car in particular. So when one day he sent me this message, I thought, he's crashed his car. Not good. So for some reason, he doesn't trust insurance companies much. So he had to make various trips around the country to gather parts in order to rebuild his car, which on a few of these journeys I accompanied him. So we had a lot of long car journeys. And on one journey, I think it was down to Dartford to pick something up, to pick up the little poppy up headlights. We were having a conversation about films, favorite films, talked about various films. And then I was telling him about this presentation and about how I need something to demo. And what he came up with was this. So this is a scene from Pulp Fiction. The man sat down, is opening a briefcase. The briefcase is said to contain the soul of another character in the film, allegedly. But what's important here is that the briefcase responds to a physical input. When you open the briefcase, a light shines out of it. So we decided that it would be fun to try and replicate this mechanism with our newly found technology. Why, you might be saying? Just because is what I say back. So what do we need for our little fun project? We need to sort stuff out for the input, the movement of the case. So the case comes up, the light turns on. The case goes down, the light turns off. So for that, I've gone with an SRHC04 ultrasonic sensor, which was in a slide earlier. It's the little blue thing with the two sensors on it. I've used them before using Python, and they're quite good, quite cheap. I think about £3. For the output, we need some light. So I got a 12-volt LED strip because one little LED doesn't put out a lot of light. So I've got a strip of them. Power. So we need 5-volt power for the Pi. You can power a Pi off just a phone charger, so a portable phone charger, or off the mains. And 12-volt for the LEDs because the Pi can't pump out 12 volts to power them. So we need a separate power supply for those. In terms of components, we need a MOSFET, which is essentially a digital switch. So it's you'll see it in the next slide. There's 3 little pins on it, and it's kind of a gate for controlling the LED lights. So we want the Pi to be able to switch on and off the LED lights. So because it's not controlling the power, it needs this little digital switch in order to say on or off. So you connect the LEDs to it and you connect the Pi to it, and the Pi says, when the Pi sends a signal, it turns them on through the gate, it allows the power through, and when it doesn't, it turns them off again. So you have to build the circuit. I'm not going to dwell on it too much because it's not really my area. But you can see I don't know if you can see my cursor or not, but at the top there, that's a MOSFET, that's a MOSFET, and you can't see the other one, but there's 3 MOSFETs because the LEDs are red, green, and blue. So yeah, you build that up with jumper wires on, this is a breadboard, which is good for sort of prototyping. When you sort of, if you want to productionize it, then you would do it a bit better. So code, let's have a look at what we did for the briefcase. So if I can find my VS Code, and it's still connected, it is. So let's push that over there. So for our briefcase, I'll start with the program.cs again. We have a few things going on here. So we have a distance sensor. So when the briefcase is closed, the distance sensor will be pointing up, and it will measure the distance for where it hits something. So if it hits the top of the briefcase and it's only, say, 20 centimeters, then it will turn it off. As soon as that distance grows, or it goes to the ceiling, it will turn it on. So we need a handler to do that, and we pass in the distance pins. So these are the pins to which the distance sensor are connected, so pins 18 and 24. We also have the LED strip handler, which takes in the LED strip pins. So again, there's 3 because it's red, green, blue. And these represent 3 pins on the Pi. I've put a little delegate in here to, when you Control-C out the program, it will turn the lights off, because when I was testing it, every time it crashed, the lights would stay on and I'd get blinded. So let's have a look at the briefcase handler. So again, it takes in these classes. These are the distance sensor and the LED handler. We've got a constant of the distance. So that's the distance at which the light should turn on or off based on the measurement. We start sensing that distance with again with a while true loop. And we say if the distance measured is greater than the trigger distance, which is this 20, then we turn it on, else we turn it off. And this is to dispose of it when we Control-C out. So up to this point, we haven't used the IoT libraries. So if we look at the distance sensor, here's where we use the HCSR04. So this is from the IoT device bindings library, which gives us a class for the specific component that we've connected, the little distance sensor. So you can delve into it, you can have a look at that class and see what it does. But again, you don't need to, it just works. So we give it the trigger pin and the echo pin. So our sensor device has 4 pins on it, 2 of which are the trigger and the echo. Yeah, it's got power, ground, trigger, and echo. So trigger is the pin that is to send out the pulse, and the echo is receiving it back. And then the time taken between sending it and receiving it back, it then calculates the distance, or this class calculates the distance. So sensor.distance. So that is how easy it makes calculating a distance using these IoT libraries. So amazing. So this returns that. If we just jump back to the handler, we've got the trigger distance. So once we've got it, we want to turn on or off the LED strip. So if we look at the LED strip handler, again, this has 3 channels, red, green, blue. So to control those, we use the software PWM channel class, which is part of the Gpio library. So software PWM is pulse width modulation. So it's to control the brightness of the LEDs. So LEDs are digital, they're either on or off. So to create the illusion of brightness, we pulse that the signal really, really fast, or not so fast, in order to make them appear brighter or dimmer. So that's what these numbers are. Again, I'm not going to get into it too much, but that just dims it a little bit, basically. And we've got one for each color. So to get mixtures of colors, obviously you vary the brightness of each LED. So to turn on the strip, we just start whatever channels we want. So we've set them up and we start them or stop them. So again, this is the wonder of these IoT classes. They just abstract everything away for you, so you don't have to worry about it. And then we've got a dispose method to dispose of those classes once we're done. So that is about it for that. So I'm going to try and do a live demo by running this. Again, it will take a little while to compile because it's running on the Pi. So hopefully not too long. So what it should do is, where's that program? Okay, so here we are. So it's running through that while loop and it's sensing the distance. So the distance it's getting is around 2 centimeters every time, and it's running the turn off method. So what would happen if you open the briefcase is it would hopefully turn on. So what I'm going to do is I'm going to stop sharing my screen, and hopefully you can see me open the briefcase, if I can work out how to do that. Oh, this is my inability with Zoom. I've completely lost my meeting controls. I'll have to exit this presentation. There they are. Ooh, don't quit. Stop. There we go. Right, so hopefully you know. So that program is still running in the background. So if I can just hopefully show you. And luckily it's got quite dark. So if I open the briefcase, the light turns on, the light turns off. So you can't see my screen anymore, but the numbers are going up. So the numbers now are around 33 centimeters. So if I open it more, it then hits the ceiling and the numbers get massive. But when I close it to about there, it's 20 centimeters. So it turns off. So doing that sort of thing on the Pi, hopefully that gives the impression that it's really easy, which it is. And it's just like kind of the tip of the iceberg. You can hook it up to almost anything you want. So I'll just mention a couple of resources that I used. Obviously the GitHub .NET IoT library was very, very helpful. There's loads of documentation on there. It's really good, really easy to use, and yeah, you just install the packages and consume the classes. I did read a book on physical computing by Tom Igo, which was very, very interesting. Lots to learn. I did find it was a little bit out of date in terms of technologies, but yeah, the code for the briefcase stuff is going to be on my GitHub, and I'll share the link. That's it from me. So any questions?
I think perhaps a round of applause would be good.
Thanks, Graham.
Well done, Rob.
Darken it now. Just turn the light on.
So personally, That was a really good presentation, and the questions I had as you were going along, actually, you answered them all. Like, how do you
Okay.
interact with the pins and all that sort
Yeah.
of stuff, you know?
Yeah, the electronic stuff, it's not really that interesting to me. So just connecting stuff up and getting the circuit built, once that's done, you just forget about it. And interacting with the pins, once you know which pin is which, again, it's pretty straightforward. I think the fact it's so cheap and so easy to get hold of, it's like 30 quid. It's just an easy gateway into that sort of world. Yeah.